SAP NetWeaver Process Integration. So, since SAP NetWeaver PI is a middleware, let's start with what is a middleware. Middleware technologies are often employed to eliminate the pain of integration. A middleware solution is essentially a layer between two systems that makes it easy for the two to communicate. It can be considered the glue that holds together applications, making seamless connectivity possible without requiring the two applications to communicate directly. In a highly distributed environment in which businesses need to connect with legacy systems, cloud applications, and business management software such as SAP and Salesforce, the role of a middleware technology is critical. With this comes a new term which is called the Service-Oriented Architecture, or SOA. So what is exactly a service-oriented architecture? A service-oriented architecture is essentially a collection of services. These services communicate with each other. The communication can involve either simple data passing, or it could involve two or more services coordinating some activity. The technology of web services is the most likely connection technology of service-oriented architectures. SAP NetWeaver PI is SAP's implementation of service-oriented architecture middleware and facilitates the integration of business processes that span different departments, organizations, or companies. The focus of SAP NetWeaver PI is how the process exchanges data with each other. Agenda. I will talk about process integration in general, and then we will continue with the architecture, with explanation of the enterprise service repository, the integration directory, runtime. We will continue them with connectivity, mapping, and routing. I will explain the system landscape directory and the importance of monitoring. Then we will have a step-by-step developing and integration process part. And lastly, I will show you on the system what we talked about. So let's get started. Process integration. PI is a middleware. It is used to solve the integration spaghetti, which is created when many systems start to integrate with each other without any central system. PI solves this problem. We are able to configure all integration and also monitor every integration from one single point. This has a lot of advantages. First of all, it reduces the integration costs. We don't have to code every single integration. PI is able to connect to any common system using any common protocol without a single line of coding. Nowadays, almost any system supports open standards like SOAP. PI is built on open standards, so integration with SOAP, services, or other open standards is very easy. Single point of integration. As explained, we are able to see all integration and monitor all integrations on one single system. PI supports all common standards like SOAP, XML, XSD, VSDL, HTTP, and many others. PI has powerful ready-to-use adapters like the SOAP or file adapter. Without writing a single line of code, you can integrate with other systems by just configuring these adapters. Even better is that you can build modules in Java for these adapters and extend their capabilities for uncommon cases. Or if you want, you can write your own adapter and deploy it on PI. You can simply integrate with non-SAP systems, again using open standards. You can use PI with BPM and BRM on a single system. This extends the capabilities of all products. The new plugin on Eclipse provides a powerful graphical editor which makes integration clearer for even non-technical people. PI has ready-to-use templates. You can also create your own templates and can reuse it on other systems and integrations. So let's move on. The architecture. In the middle, we have the Advanced Adapter Engine Extended, which is based on Java. We have the Enterprise Service Repository, where we build the design time objects. We have the Integration Directory, where we build the configuration time objects. We have the Runtime Cache, which is a mechanism which improves performance when operating integration scenarios because it minimizes the communication between the runtime engine, the Enterprise Service Repository, and the Integration Directory. Then we have the Advanced Adapter Engine, where our adapters are held. And outside our Advanced Adapter Engine Extended, we have the System Landscape Directory, which is some sort of yellow pages where we have the definition of products, software component versions, and business systems. Then we have the actual physical business systems, which we are integrating with. And we have, which we mostly don't have in scenarios, the non-central Advanced Adapter Engine, which is not that common, but it can appear. And we have on the left side the integration experts, which are us. We have the PI tool, which we use to create and configure the Enterprise Services Repository objects and the PI configuration objects. This PI tool is based on Eclipse. So let's continue. Enterprise Service Repository. The Enterprise Service Repository is a central repository where you define, access and manage data types, mappings and other objects. It is also called the design time. We define the incoming message structure, transformations and outgoing structures in the ESR. The most common objects are the data types, the message types, which are wrappers, the service interfaces, and then the mappings. So let's talk about them. Data type. A data type is a basic unit for defining the structure of the data. You can think of it as an XML element. You can also easily take any well-formed XSD and import it into the ESR. Message types. Message type is a wrapper of a data type. You will be using your message type while mapping, but not the data type. Service interfaces basically describes a single operation or multiple operations to be implemented. General attributes of a service interface include category, meaning inbound or outbound, and mode, meaning synchronous or asynchronous. Lastly, we have mappings. These help us transforming source messages into target messages. Let's continue with the Integration Directory. Integration Directory. Here you configure how your integration will work. You define sender and receiver and build your integration flow. As you can see, we have the sender on the left side, the receiver on the right side. Then we have the inbound processing. This is where we process the message. We have the routing. After the routing, the mapping which we created into Enterprise Service Repository will be called. And finally, we process our outbound message and we send it. So common objects which are used here are the business component and business system. These objects define your sender and your receiver system. We have the communication channel. Help us to define how we are going to receive and how we are going to send messages. For example, are we going to get the message via an FTP or a web service? And then we have the integration flow, also called the iFlow. This is a graphical definition where we bind objects like business components and communication channels, and define the routing. After this step, we know what kind of structure we will receive, what kind of structure we will send out, and from where the message will come and where it will go. Also, we know how we will receive the message and how we will send it out. The last step is to activate our objects also in the enterprise service repository and in the integration directory. The activation process is the process where our objects are sent to the runtime cache. From there, all the integration will work. Runtime. The business process is executed in the system landscape at runtime, which means that the process is executed and messages are exchanged between the systems involved. At runtime, a message passes through the following steps. Sender adapter processing. Based on the configuration of the sender adapter, the message is transformed technically to the XML message format the PI runtime can process. This is also called the XI message format. In case also additional security-related configuration settings apply, the message is handled accordingly. Runtime engine pipeline processing. Processing of the message in the pipeline contains the following steps. Inbound XML validation. Based on the configuration settings, the inbound message is checked with regard to the validity of its XML schema. Receiver determination. Based on the configuration setting, routing configurations, that is found in the runtime cache for the message, the receivers of the message and the routing conditions are evaluated. The receiver is written into the message header. In case multiple receivers are configured, for each receiver a separate message is created. Mapping. Based on the configuration setting that is found in the runtime cache for the message, the assigned mapping program is performed and the content of the message transformed accordingly. Interface determination. Based on the inbound interface configuration that is found for the message, the assigned inbound interface is evaluated. Outbound XML validation. Based on the configuration settings, the outbound message is checked with regard to the validity of its XML schema. Lastly, receiver adapter processing. Based on the configuration of the receiver adapter, the message is transformed technically from the XI message format to the format the receiver can process. In case also additional security-related configuration settings apply, the message is handled accordingly. System Landscape Directory. The System Landscape Directory of SAP NetWeaver, in short SLD, serves as a central information repository for your system landscape. Features. SLD stores information about all installable and installed components of a system landscape. SAP provides a web-based user interface for interactive access. SLD provides information about installable SAP software. SAP software components that are installed on technical systems are registered automatically and on a regular basis in the SLD. The SLD always contains up-to-date information about the installed system landscape. In addition, you can use the SLD to reserve component names in the SAP NetWeaver developer infrastructure. SAP NetWeaver Process Integration uses the SLD to store information about business systems which are logically connected to the technical system. Connectivity. In SAP PI, we have adapters to receive and send messages to other systems. These adapters help us to communicate with almost any SAP or third-party system. For example, we have IDOC adapters to communicate with other SAP systems using IDOC protocol. We have RFC adapter. We have a SOAP adapter. The SOAP adapter helps us to consume or to publish a web service. We have a file or FTP adapter. The FTP adapter helps us to read or write files to an FTP location. We have a JDBC adapter, which helps us to connect to almost any database. And we have also industry-specific adapters, which are the two below. Mapping. Mapping helps us to transform a source message into a target message. SAP PI provides a great graphical tool which you can use by just drag and drop. We will see mapping in more detail in the demo. Routing. Routing is used to get a source message and decide to which receiver or receivers this message has to go. Monitoring. PI monitoring allows the monitoring of distributed PI components, such as local advanced adapter engines or proxy runtimes from SAP Business Systems. Let's dive into the features. You have the following options in PI monitoring. Component monitoring, to get an overview of the status of the individual PI components. Message monitoring, to track the status of messages and to find errors that have occurred and establish what caused them. End-to-end monitoring and configuration. If you want to monitor the path of individual messages through these SAP components from start to end. Performance monitoring. You use performance monitoring to display statistical data on the performance of message processing. Index administration. You use the index administration to control and monitor the indexing for the index-based message search. SLD registration. PI components must be registered in the SLD so that they can be monitored and administered by the runtime workbench. They are registered during the PI configuration either manually or automatically using the configuration wizard. You can use the SLD registration in the runtime workbench to check whether the components were registered correctly during the configuration and to correct them if necessary. You can also register further components. Alert configuration and alert inbox. You use the alert configuration to have the system inform you of errors during message processing. You can receive the alert by email, fax, or SMS. In each case, you will also find the alert in your alert inbox. Cache monitoring. Cache monitoring displays objects that are currently in the runtime cache. How to create an integration. We have 4 simple steps for this. First, enter the system landscape directory, create a product, software component, and a software component version. If you want, you can also create a technical and a business system. Second step, create design objects using the enterprise services repository. Third step, create configuration objects using the integration directory. Fourth step, run your integration and monitor it. Let's dive into the demo and into the most fun part.